Hello everyone, hope all is well. This video lecture will be on simplifying fractions. They start off talking about factors. A factor of a number is a non-zero number that can divide evenly into it or divide into it evenly. So for an example, if you're looking for the factors of 12, you're talking about all the numbers that can divide into it evenly. It may help if you start off just thinking about what two numbers will give you 12 when you multiply them, or what two numbers evenly divide into it. So 1 times 12, 2 times 6, and 3 times 4. When you multiply them together, will give you the factors of 12. Also, nope, that's good enough. So if you had to write your list though, and they ask you for your list, you would be looking at 1, 2, 3, 4, 6, and 12. Normally you write your list in order. All right. If they were to ask for, let's see, so if they just ask you to list the factors of 12, it'll be 1, 2, 3, 4, 6, and 12. So let's say they ask you to find 4 factorizations of 12. All right. So factorization is just different ways of multiplying to get that 12. So in other words, 1 times 12 would be a factorization. 2 times 6, 3 times 4, and then also 2 times 2 times 3 will be a factorization. So if you were to break them all the way down to prime numbers, we'll talk more about this in a second. Not sure why in the book they introduce this before they talk about prime factorization, but that is how the book has given it to you. So I'm telling you what the book has in it. So if they ask you to find factorizations or 4 factorizations of 12, that's how you do it. 1 times 12, 2 times 6, 3 times 4, and then break them all the way down. 2 times 2 times 3. All right, so make sure you pay attention to your directions and what they're asking of you. Once again, the first one was list the factors of 12. So 1, 2, 3, 4, 6, 12. The next one, find 4 factorizations of 12. How many different ways could you multiply numbers together in order to give you 12? 1, 12, 2, 6, 3, 4, 2, 2, and 3. All right. Prime numbers. So prime numbers are numbers that are only divisible by 1 in itself. All right, the first few. So prime numbers go on to infinity. There's always a prime number that exists out there that's larger than the one that you know. So 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. So those are numbers that cannot be broken down any further. They're numbers that are divisible by only 1 in itself. Composite numbers is any number that is not prime. So if you can divide anything into your number evenly, then it's not prime. So any even number is composite because 2 can divide into it evenly. 21 can be divided by 3 or 7, and so on. So any number that's not prime is considered composite. All right, so talked about those to get here. Talking about the prime factorization of a number. The representation of a number as a product of prime numbers. Product means multiplication. So the multiplication of prime numbers. So going back to that 12, 2 times 2 times 3 is the prime factorization, or was the prime factorization of that 12. 21, 3 times 7. Each one of the numbers that you're using to multiply in order to show the multiplication of that number has to be prime numbers. And also, I didn't write this, for that 2 times 2 times 12, you also could represent that 2 times 2 as an exponent. So you could also represent that as 2 squared times 3. So they could ask you, find the prime factorization of a number. So here we're looking at 220. I will start off writing it as a tree, wherein I have my number up top, 220, and then ask myself what two numbers will give me 220 when I multiply them together. One, I don't know if you call it a trick, but one thing you can always remember that if you have a 0 in the back, that represents the multiples of 10. So I can write this as 22 times 10. If I had another 0 back here, that would be 22 times 100. Another 0, that means I will have 22 times 1,000 and so on. So that's always going to be a multiple of 10 if you just have a 0 in the back of your number. So that's 22 times 10. 22, two numbers that multiply together to give you 22 would be 2 times 11. Two numbers that multiply to give you 10, 2 times 5. All right. Once you end all of your tree branches in prime numbers, then that would be your prime factorization. So the prime factorization of 220 is 2 times 2 times 5 times 11. And once again, you could also represent the 2 times 2 as 2 squared times 5 times 11. All right, let's look at another one. About 198. All right, since 198 is even, it ends in 8. 198 may not be a familiar number to you, but since it's even, we know that it's divisible by 2. So if nothing else, we know 2 divides into it evenly. So 2 goes in 119, 99 times. And then, well, let me do that. So 2 is prime. If I can break this 99 down, into 9 times 11. 11 is prime, but I can break 9 down into 3 times 3. Once all my branches end in prime numbers, then I have my prime factorization. That's 2 times 3 times 3 times 11, or 2 times 3 squared times 11. All right, do one more. Let's look at 153. We know it's not divisible by 2, but it is divisible by 3. So 3 goes in 153 51 times. 51 is also divisible by 3. And that's going to be 3 times 17. All of these numbers are prime. So it'll be 3 times 3 times 17, or 3 squared times 17. All right, next thing in this section. Equivalent fractions. So fractions can have different numbers on top and bottom, but still be equal. So in other words, if I have 1/2, that's the same thing as 2/4, which is also equal to 3/6, 3/6, which is when you put it in the calculator or divide it out decimal wise, will be equal to 0.5. One way we'll be able to determine if we have equal fractions or equivalent fractions or not is by your cross multiplication relationship. If A over B is equal to C over D, and when you cross multiply, you take these denominators up. AD is equal to BC. So if I were to take that 2/4 and 3/6 and cross multiply, that'll give me 2 times 6 on the left, 4 times 3 on the right. That's 12 equal to 12. So that will always be the case if your fractions are equivalent. All right, so next exercise, fill in the blank with equal or not equal. So we will do what I mentioned earlier, cross multiply, which take 18 times 13 and 39 times 6. When you multiply 18 times 13, you get 234. 39 times 6 is also 234. So they are equal. Since they are equal, that means 18 over 39 is equal to 6 over 13. Same thing for the next one. Cross multiply. 5 times 9 on the left. 7 times 7 on the right. 45, 49. They're not equal. So that means these fractions are not equal. All right. Last thing in this section, what we been building up towards simplifying your fractions. So when your fraction is considered in lowest terms, that means that the numerator and the denominator of the fraction do not share any more or do not share any common factors other than 1. So, example of that, if I have 4 over 6, I can rewrite both numbers as prime factorizations. 4 is 2 times 2, 6 is 2 times 3. So the common terms, 2 and 2 will cancel. That's because 2 over 2 is equal to 1. So it reduced down to 1. And that leaves me with the most simplified fraction of 2/3. And so that's your fraction written in lowest terms. So you always can break down your numbers into prime factorizations and then cancel out what they have in common. So directions could just say simplify. All right, so they give you 6 over 10. 6 is 2 times 3. 10 is 2 times 5. 2's cancel. 3/5. (170 over 102). If you're dealing with numbers that may not be as familiar as you would like, you just take your time and create your tree. Remember I mentioned before, if it ends in a 0, that's a multiple of 10. So that's 17 times 10. 17 is prime. 10 is not. 10 is 2 times 5. So that prime factorization would be 2 times 5 times 17. 102, we know it's even. So if nothing else, 2 divides into it evenly. That's 2 times 51. We mentioned 51 earlier. 51 is 3 times 17. Twos cancel. 17 cancels. leaving us with 5 over 3. Next one, 20 over 24. If they are familiar to you, then what you could do is just pick out the largest factor that you see. You don't always have to go to greatest common factor. It's just up to you what method you want to use in order to cancel whatever makes you most comfortable. If you want, you could just do 4 times 5 or 4 times 6. Because you know 4 times 5 gives you 20, 4 times 6 gives you 24. 4's cancel, and you're left with 5 over 6. But if you decide to break it down into prime numbers, 20 is 2 times 10, which is 2 times 5. 24, 2 times 12, which is 2 times 6, which is 2 times 3. And we see the same thing happens anyway. 2 times 2 is 4. We have the 2's that cancel out twice, leaving us with 5 over 2 times 3. And if you have anything left, you go to multiply that out and that'll give you 5, 6. So either way, you'll get 5, 6, whether you cancel out the largest number that you know they have in common, or you cancel out by using your prime factors. You'll still get the same value. I have 75 over 25. If I look at breaking this up into factorizations, I know it's 3 times 25. I have 25 down bottom, so that's why I stopped at 25. 25's cancel, and whenever the whole numerator or denominator cancel, that leaves you with 1. So what I have here is 3 over 1, which is 3. So we write 3 over 1, even though that's not wrong or incorrect, it's not the most simplified way of writing it. So if you have 3 over 1 or any number over 1, you would just write that number. (12 over 60). 12 actually goes into 60 evenly 5 times. So that 12 over 12 will cancel. Once again, leaving you with 1, so be careful here. A lot of people make a mistake, and they will write 5. But 5 would means you got 5 over 1. This time we have 1 over 5, so that 1 needs to stay in the numerator. And that simplified fraction would actually be 1/5. Whenever you have something like this, remember I mentioned before that your zeros represent multiples of 10. So I can actually cancel out these zeros and have 17 over 3. If I could reduce 17 over 3, then I would do so. In this case, I couldn't. So that is that answer, 17 over 3. Both of those are prime. Here we have variables involved. We know 10 is 2 times 5. 6 is 2 times 3. So we know our 2's will cancel, but also these x's will cancel, leaving you with 5y over 3. All right, we do one more. So if we had to write all of this out, this would be 2 times a times a times a, 2 times 2 times a. So on top we have 3a's, that's a cubed. On the bottom, we have 4 A's, A to the 4th, and we cancel out everything accordingly. We have 2's that cancel, then we have 3 A's that cancel. So on top, everything canceled, which would leave me with 1. And on bottom, I have 2 and A. So that's 1 over 2A. All right, so let me know what you think. If you have any issues, email me.